Alright, hi, Branda's here. I'm here to teach you about limits. So I have my handy dandy program. I copy and pasted this definition from the textbook on page 51. And let's get cracking. So, I'm going to try and translate this into English as best as I can. So basically it's saying that if you have some function and you're looking at it from some interval that has a, and it's continuous around here and everything's fine, it looks like a normal function, like we're good. There is the question of, okay, well, if you have some certain point a, what is the limit of your function f of x as x goes to a? And this is a finite number. And basically what that is asking is, on both sides, you have to have some number where as the limit goes to that number a from the left, and as the limit goes to some number a on the right, what is the L that corresponds to it on the y-axis? So if we were to trace this graph, say like doing this, Alright, so we're coming from the left, so we're going to keep going and going and going, keep going until we hit A. Okay, we're good. And now from the right, okay, well, I'm going to say that. If we're coming from the left, it means that we're taking the limit as x goes to A from the left, and that's represented with a negative sign of f of x. Okay. And then we're coming from the right, going and going, going and going, increasing until we get onto A. And that is represented as the limit as x goes to A to the right with a plus sign of f of x. So what the limit says is, if these two limits are the same, both the lim as x goes to A to the left, if that is equal to the limit as x goes to A to the right, then the general limit, the limit as x goes to A, is what those two are both equal to. And that's only if these are both equal. So like if you had a function, I'm just gonna wipe that out. If you had a function like this, I'm just gonna do that. I don't know. Maybe like a piecewise function that was like this, where the limit, if you went to the right, is this right here, or from the left is this right here, say this is B, and this right here is C, then, the limit as x goes to A from the left, and the limit as x goes to A to the right, they are not equal. So the limit as x goes to A does not exist. So this is another thing to remember, that, this L that we're looking for, it's a finite number. So, and it's on the y-axis. It's pretty much the basics. The other thing I wanted to add was that if you find the limit as x goes to A of f of x is infinity, as in it keeps going and going and going, and it never actually stops, meaning it has no limit, then the limit as x goes to A of f of x does not exist, because we're looking for a limit and we don't want no limits, babe. Okay, stop. Alright, here are some properties of limits. So I think they're pretty straightforward. It's just like, okay, well, if you want the limit of, say, some function 3x squared plus 2x plus 1, it would basically, let's say x goes to 1, it would be the same as saying, okay, well, what's the limit as x goes to 1 of 3x squared, plus what's the limit as x goes to 1 of 2x, plus what's the limit as x goes to 1 of 1. Okay, now this would just be 3 plus 2 plus 1, which is 7. Nope, I can't add 6. Which is literally the same as f of 1. Because it's just like a normal polynomial. So whatever the limit, say the graph looked like, I don't know, like this. Whatever the limit is as x goes to a, it's just going to be f of a. Because there is no discontinuity, there's nothing crazy about this function. It kind of just is what it is what you see, what you get kind of function. And basically all of these are saying the same thing. Like, as long as you don't have a discontinuity and it's on a piecewise function, you shouldn't have to worry about computing the limit because it should just be an easy plug and chug. But this list of properties is just like making sure you understand that. The only thing I would worry about is probably this one. You just have to worry, make sure that g of x is not 0. Because if it is, then you need to start factoring, or perhaps the limit doesn't exist. But there are other ways you can figure out if that's true. Here I have another really important property about limits. So what this is saying is, say you have, okay, let's take this function, oops, stop that. You have this, just a line. Let's say it's y equals x. And then you have this. It's another line. Except at some point A, there's discontinuity. So what this is saying is, I don't know, say this f of x. This is g of x. G of x. What this is saying is, okay, well, everywhere except for A, these functions are the exact same. So if that's true, then the limit as x goes to A of this function is the limit as x goes to A of this function. And this is going to be really helpful because usually if you have a case like this, then you can just factor out, say, this equation to get this one. Because if they're equal everywhere except for A, then the limits have to be the same. Because there's just a hole there. Alright.